All right, we're going to answer some linear stories, and we're going to do some graphs with it. So let's do this together. Number one, Rick charges $50. Whenever I see a number, I'm going to circle it. $50 plus, that's an important word. I'm going to put a box around important words and circle the numbers. $40 an hour. And it says, let X be the number of hours that he works, and let Y be the overall cost. And then write the equation of what you see here. So X, to begin with, is the number of hours. I'm going to write that down. And Y is the overall cost. I'm going to say the total cost. So if I put it together, $50 plus 40 every hour, that's going to be 50 plus 40x. And that's what I'm going to graph. So here's my ruler. Here's my ruler. So one thing I recognize in this story is if I'm going to graph it, normally when we draw a graph, we have quadrant 1, 2, 3, 4. We draw the y-axis, it looks like a T. And these other quadrants, 2, 3, and 4, values are negative. In this story, the number of hours will only be positive, and the total cost will only be a positive number. The only quadrant I'm going to write down is quadrant number 1, because we have no negative numbers for anything else. So it's going to look like an L. Then I'm going to label each axis, and again, if it's going too quick, you press pause, right? So you can draw your axes. You can press pause. The y-axis, again, is the total cost. That's in dollars. And then the x, I don't have like a lot of room underneath here, so I'm going to put it beside, is the number of hours. So the x scale, how many hours will it take to fix? I'm just going to count by 1. And really, I'm going to go every other and fill up the scale on the bottom. All the way to 20. Now the total cost, what's the scale going to be here? That takes thinking a little bit more. So let's say it's 20 hours. If I plug 20 into this equation, that means I'm going to go 50 plus 40 times 20. So how do I go 40 times 20? Well, 4 times 2 is 8, and we need 2 more zeros there. So 40 times 20 is 800. Add 50, that's 850. So my scale has to reach up to $850. Then I'm going to count how many squares I have all the way up. So if I count, it's 20 of them. So on the side, if I go 850 divided by 20, what would my scale be approximately? And I'm thinking, well, it can't be 40 because 20 times 40 is 800, not enough. So I'm going to count my scale to be 50, because I know 50 times 20 is 1,000, and that's more than 850, and it would fit in terms of my problem that I have here. So I'm going to count by 50s, and I'm counting by 50, but I'm going every other. So every other is going to be 100, even though every square would actually be 50. And then the last thing I need, see if I got my pen somewhere here. The last thing I need is to have 2 points. So for this equation, 1 point, I'm going to plug in 0. And if I plug in 0 for x, 40 times 0, the answer is going to be 50. So can you find 0 and 50? For the second one, I'm going to use what I have right here, 20. And what's the other one? So I already figured it out, 20 and 850. So at 20, where is 850? Then I'm going to connect the 2 points together. Only one arrow, so it's not going to go negative. So there's only an arrow on the right and an end point on the other. And we were able to graph this story and understand the X and the Y. All right, let's try this again. Number 2, Rachel is a veterinarian. She charges $20 as a base and $10 for each animal she vaccinates. X be the number of animals vaccinated, and Y be the total amount charged. And it says write an equation based on this. So I want to understand. So X is the number of animals vaccinated. Y is the total cost to vaccinate them. And what equation would that be to find the total cost? So $20 is a base and $10 for each animal she vaccinates. So $20 is a base, $10 per animal. There's my equation I'm going to graph. Again, I'm recognizing that all values are positive. So we're in quadrant number 1, which means it's going to look like an L, right? We don't need a T looking. Instead, we're all in quadrant number 1 because all values are positive. So again, the Y is the total cost. That scale I'll do last. And I do have room here. The X is the number of animals vaccinated. So I'm going to start there. So the scale on the X, again, I'm just going to count by one animal at a time. So that's going to take me all the way across to 20. And then to know my scale here, I'm going to plug 20 into this equation. And I'm going to go 10 times 20 plus 20. So it's 200 plus 20, so it's 220. So if I take 220 divided by 20, how many do I need? I need more than 10, right? So I'm actually going to pick like 20 as my scale so I can get up to as high as I need. So 20 would make this 40, 80, 120, 160, 200, 240, 280, and that's as much as I need in terms of the cost. Next, I need 2 points. So 1 point will be my y-intercept. So if I plug in 0 for x and solve it, you can see 1 point's going to be 0 and 20. My second point, might as well pick the one I did, which is 20, is 220. So at 20, find 220 between 200 and 240, and then draw a line with an arrow only to the right. All right, turn the page. Pilar, I think it's pronounced differently in different languages. I'm going to say Pilar, has a side job as a dog walker. She charges a rate of $20 per walk plus $5 for every dog she takes. So X is the number of dogs walked. And again, this video is here to support you. You should try it first, right? And then if you need support, then you can get the video to support you. And Y is the cost. Write an equation. So I'm going to do it from here. $20 a walk plus $5 for every walk, for every dog she takes on that walk. And then I'm going to graph that. So again, all values are positive. So again, only quadrant number 1. So again, the y-axis is the total cost. That's in dollars. The x-axis, I don't have room like I want, so I'm going to go beside here, which is the number of dogs walked. So again, I'm just going to count by ones for the dogs walked all the way to 20. And for the scale here, again, I'm going to plug in 20 to see how much that was. So she had 20 dogs at once walking. That would be ridiculous. That's a lot of dogs at once. But maybe it's possible. Someone walking 20 dogs at once. 5 times 20, it's 100. That's $120. So it's got to get up to 120. So if I divide by 20, it's got to be more than 5. Because 5 would not get me to 120. So I'm going to do 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120, 140, no, 10, 20, and so on. I'm already there where I need to be. So I need 2 points. So if I plug in 0, the answer is 20 to begin with. And then the other one we just did was 20, and 20 gives me the answer 120. So at 20, 120 is my answer. And then connect arrow on one side only, going to the right. And you have your graph. All right, I want you to try number 7 before I do it. Press pause. Jake tutors students, charges $10 for the first session, $5 for each one after. X be the number of sessions. Y is the total cost for the tutoring. Wouldn't it be great if one day you were a math tutor and made money off of people who didn't know how to do math? And then the equation. So it's $10 for the first session and then $5 for each session after. And I want to graph that. So again, all values are positive. Money and the number of sessions are positive. So the y-axis is the total cost, again in dollars. And then the x, I have room here, is going to be the number of sessions. And again, I'm just going to count by ones. So I know this is going to go up to 20. So I'm just going to, there's my scale. Now along the y, I'm going to plug in 20 to see what value I have to at least get up to, and then do it. So 5 times 20, that's 110. So if I divide by 20, I need more than 5 again. So I'm going to count by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. What do I get? One more. And then 120. Okay. So again, 2 points. If I plug 0 in here, I get the answer 10. If I plug in, I already did, if I plugged in 20, the answer we already said was 110. So 20 goes up to 110. And then an arrow only going to the right. See if I can do this. All right, number 9. Again, you should press pause and try it. Riley cleans carpets. $30 for the job and $15 per hour. Let X be the number of hours and Y be the cost again. You can do this. So again, I'm going to write that down. This is the number of hours, and Y is the total cost. And then the equation, you already wrote it down. It's 30 plus 15x. Then again, all values are positive. So it's only quadrant number 1. We know these count by 20 by 20 by now, so we're just going to be simple. You're going to count every hour up to 20. This again is the X, which is the number of hours. Here on the Y is the total cost in dollars. Let's see if I can spell. Doing okay. And again, I want to plug in 20 to know what the total cost is for 20 hours. So 15 times 20. So 15 times 2 is 30, so that's 330. And again, if I divide by 20, which scale makes sense to a good whole number? 10 is not good enough. 15 is not good. I'm actually going to count by 20s because 20 times 20 is 400, so it's a scale that can reach. So 20, that's 40, 60, 80, 120, I should count 140, 160, 180, 200. What am I going to have? 330. Okay. 220, 240, 260, 280, 300, 320. We're almost there. 40, 360. All right. So, counting by 20s, there we go. So 2 points to graph. So I'm going to start with 0 again, which is 0 and 30. Now I did count by 20s, so 30, I'm smart enough, is in the middle between 20 and 40. You could do it too. You're smart enough. 20 gave me the answer 330. So at 20, where is 330? That's in the middle here between 20 and 40. So in the middle, and then connect it. Only an arrow going to the right. All right, turn the page. Let's read this together. This one's a little more challenging, but we'll do it together. A local store spent $10 on 144 pencils. What is the equation for the profit if each pencil sells for 50 cents? And then we're going to graph it. So we're going to read the problem and reread it, determine the quantity. So X is going to be the number of pencils, and Y is going to be the profit in dollars, how much money we made on that. The slope and the y-intercept. So we're going to look at the question and understand in terms of the profit. So this is going to take a moment to find these two things. So the first thing I actually need to find, I'm going to cross it out, is the unit cost for the pencils. So how much does one pencil cost if 144 costs $10? So the cost per pencil, so we're going to go cost per pencil, so cost on top. You would divide $10 divided by, and I'm going to do it for you. You would definitely use a calculator. And the cost per pencil is 7 cents. If I want to know the profit then, how much are we selling the pencils for? Subtract the cost, and each pencil we're selling, we're making a profit of, once we sell how much it costs, 43 cents. That 43 cents ends up being the slope of what I'm looking for. Then it says substitute the slope and y-intercept into this equation. So the equation is going to be the slope. Now what's going to be the y-intercept? And the easiest way to understand this is if you sell no pencils, so x represents the number of pencils. If you plug in 0 for x, how much profit will you make if you sell nothing? And the answer is you will have no profit. So what you don't see at the end, the y-intercept, is 0. Then change this to a fraction. So 43 cents as a fraction is 43 out of 100. And again, I don't need to put plus 0. I already rewrote the equation using this fraction. And then can I graph this equation that shows the profit? So let's see if we can do this together. We can. So again, all values are positive. So I'm just going to draw the first quadrant. It's like a big L. Again, it's a 20 by 20, so I can save time understanding that. But for this one, it doesn't make sense for me to just sell one pencil at a time. I'm not making any money selling 1 or 2 pencils. I need to sell hundreds of pencils to make any money. So instead of understanding this in terms of 1, 2, 3, I'm going to understand it in terms of 100, 200, 300, and so on. So I'm going to have 100, 200, 300 pencils sold, 400. It's going to be easier to graph to understand the scale better. 6, 7, 8. I'm going to go to 1,000 pencils sold. We got to make a living, right? We got to put food on the table. 1 or 2 pencils is not making enough. We need to get more money every day. 1,000. Now, we have our equation, 43 over 100x. If I plug in 1,000, $100 goes into 1,000. 10 times, and then 43 times 10 is 430. So 1,000 gives me 430. That gives me my scale. So if I divide by 20, 20 is not enough. So I'm going to do a scale of $25. So 25, 50, 75, 100, and I'm going to use that scale going up. And again, this is the Y, this is the total profit in dollars. Then I need 2 points. So 1 point, if you plug in 0, 0 times anything will give you the answer 0. And the second one is the one we just came up with, which is 1,000 and then 430. So I'm going to find 1,000 and approximately where 430 is, which is just above 425. And then I'm going to connect and make an arrow going to the right. If we wanted a table here, we said X is the number of pencils sold, and this is the profit. So we know if we don't sell a pencil, there's no profit. If you use easy numbers, like 100 would give me the answer 43. 500 would give me the answer 215. And then we just said 1,000 pencils gives me 430. And then we used the first point and the last point to draw our line. We already did this. And number 8's done. Perfect. All right, let's turn the page. A taxi company charges $2.50 per ride for $2 for every mile driven. Write and graph an equation that would model that. So right away, let's just get to it. We know all the values are positive. So we know we have this L. The x-axis and the y-axis. So the x-axis is how many rides, right? So this is going to be the number of rides. And then the y-axis is going to be the total cost for the taxi ride in dollars. My equation is going to be important, right? So it's y equals, it's $2.50 per ride. $2.50 per ride plus $2 for every mile driven. All right, so we have the number of rides. Oh, this is the number of miles. I made a mistake. So let's do this right. So when you get in for a ride, it starts with $2.50, and then every mile is $2. That's what it's going to look like. And so we have the number of miles and the total cost. So we know this is going to go to 20. We know if we plug in 20, how much does that cost? 20 miles is $40. So $2.50, 2 times 20, that's 40, and then $2.50 more. So we know we have to at least get to $42.50. So if I divide it by 20, I need more than 20. So I'm going to go 25, sorry, more than 20, more than 2. So I'm going to count by 3 in terms of how much it would cost. So 3, 6, 9, 12. It's okay if you count it by 5s. 15, 18. Can I count by this? 24. I know my times tables. Almost sure of it. See if I make a mistake or not. We're going to get up to $42. All right, there we go. So next I'm going to graph this. So 2 points. So I know if I plug in 0, the answer is $2.50. I'm going to estimate that. So that's $3. So $2.50, just a little bit below there. I'm okay estimating. And then the other point we used was 20, and it was $42.50. And again, I'm okay estimating that. So 20, where's $42.50? There's 42, a little bit more than 42. And then I have 2 points to draw my cost for a cab. Arrow to the right. Next one, Miranda. Miranda gets paid $300 every week to deliver a grocery. Also earns 5% commission on the total cost of the order she delivers. Write an equation that represents her weekly pay and then graph the equation. We know already these are all positive values, so it's like an L, first quadrant. And we need to know our quantities and think through what our quantities are. And it says it in the question. So X, right? That's $300 every week, and then 5% in terms of the total cost in terms of it. That's 300. Now 5% is 0.05 X. So X is the total cost of the order. Now that's different than the Y, which is how much she gets paid for her job. So how much is she getting paid for her job, and what's the total cost of the order? So again, I'm probably not going to go by dollars in terms of groceries, as she gets paid $300 a week plus and so on. So what is the total cost of the order? I'm going to just count by 50s. So that's 100, that's 200, that's 3, might be too much, but that's okay. 300, that's probably enough at 300. Maybe that was too much. All right, let's count by 50s. So 50, 100, I think that was a little bit aggressive. 150, 200, 250, I know my message is awful. 300, and at least we have the total cost of the order there. Let's keep going. 350, 400, and let's get to 500. That's a lot, but maybe they have a big family. $500. So if I plug in 500, I can do this. You can do this. 0.05 times 500. So we have 300. How would I do this? Well, I know what 5 times 5 is. That's 25. And if I move the decimal in terms of understanding it, the 0.05 and the 2 zeros, the whole thing is actually going to cost $25. That's 5% of 500. 5 times 5. So this whole, how much she gets paid at the very end is $325. So if I divide by 20, $20 is going to be a pretty good scale to use here on the Y. So I'm going to go 40, then 80, then 120, 160, 200, 240, 280, 320, 360. There you go. Now, to graph this, 2 points. So if I start at 0, if I plug in 0 for X and multiply, I get 300. So I got 0 and 300. Oh, that's not 300. This is 300. Sorry. It's going to be a pretty flat because the slope is 0.05. So it's going to be very flat looking. And we need another point. We just did it, which is what? 500 and, what did we say it was? 325. So 500, where's 325? Like here. Oh, and then draw a line. So you can see how flat that is. Still rising. All right, number 4. The velocity of a ball thrown directly upward can be modeled with the following equation. And v is velocity and g is the acceleration due to gravity. It's negative because the ball's down. So t is the elapsed time, and v sub 0 is the initial velocity at time 0. So we're going to plug in, if the acceleration due to gravity is 32, which it always is, no matter the weight. So that's going to be negative 32t. And the initial velocity is 96. So v sub 0 is 96. There's my equation. You could also write it like this if you just hate those letters. Just like that, if you hate it. Negative 32x plus 90. What's the equation? And then graph it. So we just came up with the equation. if we graph it, let's make sure we understand both. I'm going to graph it in with these letters, but it's the same if you graph it with the other letters. Yes, you should be comfortable with both letters. So I'm going to call this T. T represents time, and it's in seconds. And then the other one is V, which represents velocity, which is in meters per second, feet per second. So, and then we need 2 points. So 1 point is going to be 0. Oh, we need to know our scale, right? So how many seconds are we going to go? So let's go to 20 seconds. So 0 to 20 seconds. So if I plug in 20, that's negative 32 times 20 plus 90. So negative 32 times 20 is negative 600. We're going to have negative values here for velocity, right? So I need to rethink this, but I'm going to. So negative 32 times 20 is negative 640, and then plus 90 is negative 550. So I need to be careful here. When I plug in 0, the answer is 90. So there's a scale going to change. We have negative values. So I am going to do this. So first of all, yeah. So I'm going to change it. I'm going to draw the axes right here. Ignore this. This is my T. This is 20 and 0. This is wrong. And then I'm going to start. So from 0, what would make sense in terms of this is I'm going to count by 50s. So we have 50 and 100. And then going this way, I have negative 100, negative 200, negative 300. A negative velocity gives me direction. So because it's falling, it's negative. So it's going that speed, going down. That's why it's negative. Speed is always a positive value. All right. And then I'm going to find my 2 points. So 0 and 90 is one of them. That's here. And then the second one is going to be 20 and negative 50. So 20 and negative 550. You can see that the slope is negative because the velocity. So when the ball first, the shape of the ball, it gets thrown up and then it goes down and hits the ground. When it's going up, the velocity is positive. So at this point here is when it changes direction. So above means it's going up. And as soon as it's below, that means the direction is down until it hits the ground. And we don't know how tall we are to begin with. So we don't have that at all. We don't have the position of the object. We only have the velocity of it. All right, one more like this. A Boeing 747, an airplane, starts out and it has this many gallons. And I might use a calculator support, and I have one ready in its tank. The airplane uses 5 gallons per mile. Write an equation of this. So we're going to use y again. So we start off with 57,260, and then we're losing, it's a 5, even if it doesn't look like it, 5 gallons per gallon. 5 gallons per mile. So this again actually has negative values for y, but not for x. So before I do my scale too much, I'm going to plug in how many miles. And so 20 miles does not make sense because a plane flies pretty far. So I'm going to plug in 2,000 miles as my end amount. So every 100. And if I plug in 2,000, 5 times 2, that's 10. I just plugged in an easy number so I could subtract it easily. 5 times 2, that's 10. And 3 zeros, that's 10,000. So if I subtract it, that's what I get. Oops, that's a 4, right? 47,260. So everything is still positive because if I had negative fuel, I'd be in trouble, right? So I'm going to still do this. So negative fuel means, it's done, it's hitting the floor. So now that. So these are the numbers I'm looking at. What should I count by? How about 5,000? And this is, y is the number of gallons left, and the x is the number of miles the plane flew. So I'm going to go 1,000, 2,000, 3,000. Am I going to get there? I'm not going to get there by doing that. 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. We'll just do that. It's going to be an estimate anyways. And then here, we're going to go by thousands of miles. Sorry, hundreds. All the way to 2,000 miles. That's not 2,000. There it is. So counting by hundreds to get to 2,000. Then we're going to plot 2 points. So 0 is going to give me that 57,260. So I'm going to estimate where that is. And then the other number we just did was 2,000. Gives me 47,260. So 2,000 gives me 47. Somewhere here. And you can see again, the fuel is declining as you're going the number of miles you are. And you could extend and see when will it be 0 to know how many miles could you go if you use 5 gallons of fuel per mile. All right, turn the page. This is our last one. A frog is about to hop from the bank of a creek, And the path of the jump can be modeled by this equation, where h at x, which is just y, is the frog's height in feet, and the x is the number of seconds. That the frog is in the air. And it says a fly is cruising at a feet of 5 feet. Is it possible for the frog to catch the fly? And so I'm going to take this equation, negative x squared plus 4x plus 1, and make it equal to 5 feet. So this represents the height of the frog. Could the height of the frog get up to 5 feet? So make it equal to 5 and solve it. So I'm going to make it equal to 0. I'm going to add x squared. I'm going to subtract 4x, and I'm going to subtract 1 to make that 4. And then I'm going to solve this by factoring. So two numbers that multiply to 4 and add to negative 4. And then notice both of these, if you would solve them, are the same equation. So I'm not going to do it twice. And you can say, yes, is it possible for the frog to catch the fly? And the answer is yes. And the answer is at 2 seconds, the frog will be at a height of, 5 feet. Okay. Then over here, they ask some questions about it. So I have this equation, y equals negative x squared plus 4x plus 1. So can the frog catch the fly without jumping? No. The frog must be 5 feet above the creek. So you have to jump to get 5 feet above the creek. Is there an extreme max or min? Yes. So there is a point where it jumps and then comes down, right? There is some kind of maximum. So there's a maximum. I'm going to tell you there's an equation. And this is the equation to find the maximum. It's negative b over 2a. So when I look at the equation, it's going to be here for the vertex. I look, the first number is A, which is -1. The second number is B, which is 4. And so I put into this equation here, negative B, which would be -4, divided by 2 times A, which is -1, and then I solve it. So if I solve that, the x value is 2. So that's the x coordinate. To find the y value, I plug 2 in and then solve it. So you can see that this will give me the height. So that's -4 plus 8 plus 1. That's 5. So we have a vertex at 2 and 5. If the frog jumps to catch the fly, is it possible for the frog to catch the fly? And the answer is yes. And we showed it over here on the left why. And in the sketch, right? So I'm sketching this one, right? -x² plus 4x plus 1. So I know a point that if I plug in 0, the answer is 1. This is the y that represents feet above the creek. So it actually starts a foot above the creek somehow. And then this is seconds. That's the x. So if I go 1, 2, 3, 4, I know that we have a point here. We know at 2 seconds it goes to 5 feet. 2, 3, 4, 5 feet. And with an axis of symmetry at the same line, then therefore at 4, 1 we also have a point. And so it starts a foot above the creek, and then eventually it lands back in the water sometime after 4 seconds. It won't go negative. There's the water. And then if I add the flight of the fly is flying. It's not negative. So the flight of the fly is exactly at 5 feet. So at what moment will the frog and the fly meet and the frog is happy is exactly at 2 seconds. All right. Thank you for sticking with me. I know it's not easy. I'm glad we did it together. Mr. G Math over and out. Till next time. I'm proud of you for trying your